This is our power plant project. This project is done by Kathleen Delianovas, Alexander Patterson, and Brendan Ziegler. The team name is Peter Piper picked a peck of power plants, a fun tongue twister. So this slide has our design on it, and as you can see, it's labeled with states and the flow and how our project works pretty much. So our Rankine power plant includes a boiler, 2 turbines of high and low pressure, a condenser, a pump, a closed-feed water heater, and a throttling valve. After the flow exits the high-pressure turbine, the flow is going to split. 22% of the flow is reheated by the boiler and then sent to the low-pressure turbine. The remaining amount of the flow enters the closed-feed water heater in order to preheat the fluid of the cycle before it enters the condenser. We found that these main characteristics allowed us to maximize our workout and the efficiency of the cycle. So our next slide is our TS diagram, and as you can see, it's labeled with points and shows which way it'll be going in orange, and our pressure states are also on there. The TS diagram shows the location of each state and the flow in relation to the vapor dome. Our TS diagram matches what a TS diagram for a Rankine cycle with 2 pumps and a water feed heater should look like. It shows the different states' pressures, temperatures, and their enthalpies. This diagram is based on the pressure coming out of the boiler at 16 megapascals, since that's the value that gives us the highest efficiency in workout and does not exceed our limits. Our flow of water throughout the cycle changes accordingly and follows a correct Rankine cycle.
Next, we have our parametric study. We conducted this study to test the best pressure that works across the boiler and then enters the turbine. This occurs where state 1 was located on our diagram above. We showed the corresponding efficiency of the cycle and the total workout in megawatts. The results show that as the pressure in the boiler increases, the greater the efficiency in work generated. This makes sense because boilers are more efficient at high pressure, which will maximize the final efficiency of our cycle. Continuing from the parametric study above, here are a few plots to show the relationship between the workout versus the pressure and the final efficiency versus the pressure. These plots show a clear relationship that as the pressure in the boiler increases, both the workout and the efficiency of the cycle increase. For the overall cost-benefit analysis, we pay for the price of 2 new turbines, 1 feed water heater, and 1 pump used. However, as we earn money for each percentage of our efficiency that is above 39%. So with an initial budget of 18 million and only using 17 million of that initial budget, we end up earning $21.1 million from the efficiency savings, and then our overall cost-benefit analysis lands us at 4.1 million saved.
Here is a section from the Maryland Power Plants and the Environment Report. It states that it is important to use clean and renewable energy. Because of this, we decided to use water for our Rankine cycle, which while it may not be the most efficient working fluid, it is an environmentally friendly substance to use. There are no chemicals in the water that could cause harm to the environment. Another section from the Maryland Power Plants and the Environment Report states that there has been an increase in the generation of energy from renewable sources, leading to a reduction of CO2 emissions by 52%. The focus we had for the design of our power plant was to not have any carbon tax, meaning our power plant would leave a smaller carbon footprint on the environment. In order to avoid a carbon tax, we made sure our heat input did not exceed 230 megawatts. Another way to further reduce our carbon emissions, according to another section of the Maryland Power Plant and the Environment Report, is to use low sulfur coal at combustion and have a higher combustion efficiency. Our efficiency is 41.11%, and because it is above 39%, we are saving $21,100,000 over the plant's lifetime in reduced carbon tax. Thank you for watching our presentation. Please email myself, Brendan, or Kathleen if you have any questions, comments, or concerns. We are Peter Piper picked a peck of power plants. Thank you again, and have a great day.